Welcome to the DD1324 online lectures. In this lesson, we will cover pointers and arrays. Pointers and arrays are closely related in C. You can manipulate arrays in a manner very similar to how you can manipulate pointers. Remember that arrays are data of the same type stored in a consecutive block of memory addresses. So, for example, if we declared A as an array and P as a pointer to that array, we can use the following manipulations to look at the addresses of the array. So for example, the standard way that you would look for the first address or the address of element I in the array is to put ampersand to get the address, and then A, and then square brace for element I. Alternatively, you can also use the following methods where you use parentheses and you say A, which gives you the base address of the array plus I, or P plus I. These will all give you the address of element I. Similarly, if you want to access values from the array, the standard way is to say A and then square braces I. But you can also use the following syntaxes. You can use a pointer with square braces of I, or the dereferencing with parentheses, and then you can add I to the pointer address, or since A is the base address of the array, you can also do the same syntax with A. So let's look at the following example where we create an array with 5 elements, 90210, and then we create a pointer to an integer type, and then we assign the pointer to point at A. So this is equivalent to saying P is equal to ampersand A with square braces of 0. So pointing it at the 0th element of the array A. So you can see in this first statement, we're printing the location in memory of just the base address of A, and that gives us 202. So the location of the integer 9. Similarly, if we say ampersand A with square braces for index 0, it gives us the same address 202. And if we also print the address of the pointer, it's the same, 202. If we want to get the value of the ith element, let's say the ith element, in this case we just want the first element, element 0, the standard way to do it would be to say printf with a %d for integers and then A square braces 0. But in a similar way, we can use the following syntaxes. You can use the pointer dereferencing star with the A for the base address of the array, or you can use the pointer dereferencing with the pointer variable in identifier P, or you could say P with square braces of 0, just like you would say A with square braces of 0. These are all valid ways to access the array. Let's say that now instead of wanting to access the 0th element of the array, we want to access the first element. So we can declare a variable integer I is equal to 1, and now all of these statements here where they're using I have different values. So if we want to find the address of the first element of A, we can write the ampersand to get the address, A, and then square braces of 1, and that will give us the address 206. Similarly, we can use parentheses and A plus I, or parentheses P plus I. Those all give you the value 206. If we want to get the value contained at memory address location 206, we can use the standard way where we say A square braces of I, and that'll give us 0, the contents of that memory address. Or we can use the dereferencing, star and then parentheses A plus I, or star and parentheses P plus I, or P of I. Those are all valid ways to get the 0 from 90210. Similarly, we can adjust this I to be 2 or 3 or 4 or even 5 will give us this address location, or yeah, all the way up to here. We can even access this if we give the correct index here. An important type of array in C are strings. Strings in C are just arrays of type char where the end of the string is denoted by the null character /0. Strings in C must always be null terminated, and the size of the string is always the number of characters plus 1 for the null character. Let's look at this small snippet of code here and see how we can create a string from a character array. Here we create a char array S and give it size 10, and we initialize it with the literal hello. We then create a char star pointer and we give it the base address of the string S. Alternatively, we could write this: char star p is equal to ampersand s of 0. That would give the same thing. It would point it at the base address of the string, which here was 202, the location of the h. Here we have a printf statement, and in this printf statement we give it the special %s formatting, which tells it to print out the string up until the null character. We can do the same logic using a while loop, as we can see right here, using the pointer and a while loop. So here we're checking while the value at the location the pointer is pointing at, it does not equal the null character, then we print the character pointed at by the pointer and we increment the pointer. So what this does is it starts the pointer at 128, or at memory location 202. So it points originally at 202, and then it checks to see if the value in 202 is equal to the null character, and if it isn't, it increments the pointing to s of 1, and then to s of 2, s of 3, s of 4, and finally s of 5, where it hits the null character and it exits. Each time as it's going through this loop, it's printing out the character that it finds. So here you can see star p, it's dereferencing, so getting the value at the location at the address that it's pointing each time. So it points at 202, 203, 204, 205, 206, and then 207, and it leaves the while loop. In C, we do not have true multidimensional arrays. However, you can make arrays of arrays. So a two-dimensional array in C is, in essence, a list of one-dimensional arrays. So we can remember that if we wanted to declare a one-dimensional array, we could say integer array of b of length 3 is equal to 1, 2, 3, and then b of 0 is equal to 1, b of 1 is equal to 2, and b of 2 is equal to 3. The elements of b are integers. We can declare a two-dimensional array as two one-dimensional arrays, each of 3 elements, and we can do that as follows. Integer a of 2 and with square braces and 3 with square braces, and we can initialize it as follows: curly braces and then the first array, and then comma, the second array, and then close the curly braces. A of 0 has a three element one-dimensional array, and so does A of 1. The elements of A of I are always arrays of size 3. We can see here in this depiction of the memory how this array is actually stored and laid out inside of the memory. You can see that it's going sequentially 0, 1, 2, 3, 4, 5, where first we have the first row, or the first one-dimensional array, and then the second one-dimensional array following it. If we want to access these elements, this is A of 0 of 0, A of 0 of 1, A of 0 of 2, and this is A of 1 of 0, A of 1 of 1, and A of 1 of 2. We can also access this memory address by A of 0, which is pointing to the beginning of the first one-dimensional array, and we can access 412 by A of 1, which is pointing to the second one-dimensional array. As it is with arrays in C, there are many equivalent ways of writing the same thing. For example, if we look at the different ways we can write the base address or the beginning of the array, so this memory location 400, there's several different ways we can write it. The standard way would be to use the address of A00. Another way would be to use the base address of the array. Another way would be to use the address of the first one-dimensional array, A of 0. Another way would be to dereference the pointer A, which points to A of 0. And finally, we could also use the value of the pointer A of 0. If we similarly wanted to find equivalent ways of printing the address of the second row of the array A of 1, 412, there's again many ways we can do it. We can start with the address of A10. We can also use some pointer arithmetic, so the base address plus the size of one array, or one one-dimensional array. We can also use the address of A of 1. We can also dereference the pointer of A plus 1. And finally, we could use the value of the pointer A of 1. There are several equivalent ways also of getting the address of the third element of the second row, A of 1, 2. The standard way would be to use the address of A12. Another way is to use some pointer arithmetic. So first we add 1 to the base array, and then we add 2 to the second array. And the last is also to use some pointer arithmetic, where we say a of 1, which starts us here at 412, and then add 2. If we wanted to create a for loop to print out the values of this array, we could do it simply like this. We could create a looping variable I, which goes from 0 to 2, and another looping variable j in a nested loop that goes from 0 to 3. And then inside of the loop, we could print %d and then a of I comma j, or a of I square braces j square braces. And between the loops, we can do a printf statement. This will print out the array just as we had written it. If we wanted to print out the value of the second element in the first row, a of 0 of 1, there's several ways we can do it. The standard way would be to just use a of 0 of 1 in the printf statement. Another way would be to use some pointer arithmetic with some dereferencing. So here we can say a of 0, which gives us the base address, and then plus 1 brings us here, and then we can dereference that. In general, we can do indexing in using pointer arithmetic using the following rules. A of ij is equal to star and then parentheses a of I plus j, or star parentheses star plus j, and then inside of that star a plus I. It's important to remember that to pass a multidimensional array as a function argument, you must make sure that the function argument matches the type of the variable that you declared for the array. For example, here we declare an array of dimension 2, 3, where it's initialized with values 0, 1, 2, and 3, 4, 5. The type of A is a 2 by 3 two-dimensional array, or also it's an array of 3-element one-dimensional arrays, and therefore the following are all valid function declarations to handle this input data type A. The one that is most obvious is to use int of a 2, 3. But you can also use these first two, which do not specify the number of elements in the first dimension, but only specify the size of the 3-element second dimensional array. This is a useful cheat sheet for using pointers with multidimensional arrays. If you'd like to declare a one-dimensional array with a name A of type T and length N, you can do it using this format. Here's an expression for getting the address of the first element in A, which is identical to saying ampersand A of 0. This is also an address of the array, same as the above. Here's a way you can get the value of A of 0 by dereferencing, and here's how you can get a value at A of I. This is another way you can get the address at A of I, and here's how you can get the size of the number of bytes in the array. There are similar expressions here for two-dimensional arrays or higher dimensional arrays. This concludes our lesson on pointers and arrays. Thank you for watching.